Hello everyone, this is Kikoto Mani from Team Get Wreck Robotics, as well as a member of Team WPI. Welcome to the build process, where I show you how I build a combat robot from beginning to end. This episode is going to be a special one, as we will be putting together the last bot I need for T-Town Beatdown on August 3rd. We will be rebuilding my Beetleweight drill robot, the Power of Friendship. I have made a lot of robots over the years, but the Power of Friendship may just be the best bot I've ever built. What started off as just an experiment to see if drills could be effective in modern robot combat quickly spiraled off into something greater. The Power of Friendship absolutely exceeded my expectations at the NHRL January New Bots event and managed to finish in the top 16 at 3-1, making it my most successful performance at an event ever. Not to mention, the win against misdirected aggression is without question the single greatest moment of my entire robot fighting career. Also, the fan response to the Power of Friendship has been just incredible, and so it only makes sense to bring them back better than ever. I actually have a lot planned for the Power of Friendship in the coming months. I have signed them up for the September NHRL event, and hopefully, if they get accepted, they can do just as well, if not better than last time. The Power of Friendship will also be competing in Mass Destruction on August 24th. However, before all of that, the Power of Friendship will be fighting in T-Town Beatdown on August 3rd, along with some of my other robots. T-Town Beatdown specifically will be a very interesting event for the Power of Friendship to fight at, mostly because of their different rule set to NHRL. At NHRL, Beetleweight multibots get a 1-pound weight bonus, and that's why the Power of Friendship is usually a 4-pound entry that consists of two 2-pound bots. However, T-Town Beatdown does not have weight bonuses for multibots. This means I will only be allowed to fight with one of the Power of Friendship bots at a time. With all that out of the way, let's get into the redesign. Alright, so here's the CAD for the new Power of Friendship. Real quick, I want to clarify that even though I just said that only one of these bots can fight in T-Town Beatdown at a time, I'm still going to build both of them anyways. And I'm mostly doing that because in robot combat, you really need a lot of spare parts. And so that's why a lot of people actually bring multiple copies of their robots, because they would want to have enough spare parts to make entire copies of their robots. So at that point, they just bring entire copies anyway. So similarly, I would want to have enough spare parts to make a second Power of Friendship so I could rebuild everything if I needed to. But at that point, why not just make a second Power of Friendship? So yeah, I'm going to be bringing both bots, but only fighting with one just to make repairs easier, and I can swap between bots whenever I need to. And also, I don't want them to be lonely. Like, they're siblings, they got to be together. So we're keeping the Power of Friendship together, even if they can't fight in the arena together. So yeah, I'm still going to build both robots. Anyways, looking at the CAD, so a few differences. Like the Power of Friendship, they haven't changed too much. The most obvious difference is the change of the forks. Instead of having 2 forks, I now have 3 forks. And those 3 forks attach to this new fork mount. So it's just one solid piece, as you can see there. So just going to the assembly again, we're just going to look at just one of the Power of Friendship. So you see here that it just slots right into the squares for the main body. And in fact, actually the main body, so talking about that, we have the mount where the servo goes into. We have the places where the motors fit in. We actually have these little guards here. That's the thing a lot of robots do. They just make sure that the cans of their brushless motors don't connect with wires, so that can cause problems. So they put something in between there to shield them. So I just have this wall just to make sure that no wires or nothing gets in the way of the back of the motors, just to make sure nothing really goes wrong here. So aside from that, the bots are mostly the same. There really isn't a lot of difference. The only changes again are the forks and the drive motors, which I'll talk about more. I did change the drive motors, which I'll talk about more in a little bit. Oh, another thing I changed, speaking of drive, is that I'm switching from the FingerTech foam wheels to Flex Foam 23 wheels. So that's nice. But But yeah, again, the bots are pretty simple. Not a lot of changes, because, I mean, they did pretty well at the January event. Their only loss was the Catalyst. Painful loss was the Catalyst. But hopefully, with this new fork setup, better drive motors, and all that kind of thing doesn't happen again at this next competition. So, yeah, let's get the building. All right, let's start talking about the parts and electronics we'll be using. So, the biggest change for the Power Friendship are the drive motors. So the Power Friendship used to use these FingerTech Megasparks brushless drive motors, and yeah, they're pretty good. Like they're the first brushless drive motors I've ever used. I used them in Kill with Fire, I used them in Serial Killer, and I used them in the Power Friendship, and they were nice. However, something smaller and lighter has come along, and those are the Repeat Compacts. As you can see, they're more compact, as the name implies. They're smaller, and I think they're about 30 grams lighter, which is great. So, you know, when every gram counts, you just got to know what to use. And yeah, I've heard good things about these. Some of my friends have used them, and yeah, they're pretty great. So yeah, like I said, the biggest thing is that they're smaller and lighter than the previous motors, so there's no real reason not to use them. So yeah, I'm happy to try these out for the first time. Then we have the FingerTech hubs. This is what we're going to be attaching the wheels to. We'll talk about the wheels later, but these are the hubs that they attach to. And yeah, the FingerTech twist hubs, I've used them a bunch, and yeah, I'm pretty happy with them. Then we have the ESCs. So I'm probably gonna switch to different setups for drive motors later on in the future. But I just have a bunch of these ESCs lying around, so I might as well use them, especially since I'm trying to save money, because I've spent a lot of money on robots recently. So I gotta use whatever I got. So I have 3 of these ESCs. 2 will be for the drive motors, and 1 will be for the weapon motor. And this is the exact same setup I used in the last version of Power Friendship, and it worked out fine, so it should be good here. Then we have the weapon motor, very basic brushless motor. Again, I bought a bunch of these in bulk a while ago, so I might as well use them while I have them, so that's what we'll be doing. Here's the drilled chuck with the drill bit that will attach to that motor. We'll talk more about this later too. We have the Beck, of course. Then we have the servo for the arm. This is a 20 kg servo. And yeah, I've used these exact servos in almost all of my bots. Not only have I used them to Power Friendship, but I used them in Serial Killer and Kill with Fire. And yeah, it's a really powerful servo that gets the job done. So just gonna, if it ain't broke, don't fix it, you know? So we're gonna use that again. We got our 4S battery and our receiver. Obviously, there's some other stuff that's missing, like the TPU stuff and so on, but we'll get into that later. So yeah, this is just what we're starting off with. All right, let's go ahead and what we have so far, just to get a general idea of where we're at. So again, just to reiterate, so for this Pacific competition, we're going to be fighting with 1 Power Friendship bot that weighs at the 3 pounds or close to 3 pounds. But we also want to design the bot in such a way that we can go back to making each robot 2 pounds for the events that do have the weight bonus. So just a little reminder there. Oh, I dropped the drill bit. I dropped it. We're keeping that in though. Okay, then the servo, the receiver. Okay, so yeah, the electronics are pretty light. They're about 342 grams. And so yeah, that leaves plenty of weight for everything else. And like the best part with that is that, so like with the TPU stuff, we can kind of mess around with the infill and wall density. So like when we first make the robot to be about 3 pounds, whenever we want to go back to 2 pounds, I think I can just mess around with the infill and the walls and so on just to get it back there, since the electronics aren't really holding us back in terms of weight. So yeah, looking pretty good so far. Let's get into the next step. All right, so here's a look at our first batch of parts we'll be printing. These are the orange parts. We have the main body, the top panel, and the weapon arm. I'm mostly showing this because I just think it's really cool to see the 3D printing process. So this light blue stuff, those are support structures. Since if you're not 3D printing something completely flat, you need a support structure so that it can print above that. We have the support structures on all the holes and slots and whatever. And yeah, so again, this is going to be 3mm walls, 10% infill. And if we want, we can just change that if we want to add more weight or take away weight and be lighter or whatever. So yeah, this should take about a day to print. And then after that, we can start on the fork mount, which is going to be in blue. So yeah, we're going to print the orange parts first, test fit everything, make sure we're good, and then continue from there. So yeah, let's get to it. Okay, so now that the TPU parts have finished printing, let's take a look at each of the individual parts, just see how everything fits together. So first off, we have the main body. And it came out pretty well. So as you can see, I've already attached the drive motors. They just face mount to the TPU. And yeah, they should be held on pretty well. I've done face mounting for a bunch of my other bots, and I've never had any real problems with that. So might as well keep it here. The servo just press fits into this opening for it, and it's actually held in pretty snug. And lastly, there's these little gaps there just to help put some of the wiring through. So yeah, overall, I'm pretty happy with this. All right, now I'm really excited to talk about the weapon arm and how that works. So here it is. As you can see, the TPU arm has finished printing, and it came out pretty good. So I have gotten suggestions to put some kind of carbon fiber side here in order to increase rigidity. And I really want to do that in the future. I just don't think I have the time or money to do that for this specific event. But I'm probably going to do it for like mass destruction and NHRL. But for this specific event, I'm just going to have the pure TPU arm. However, it's a lot more, it's not as bendable as you'd expect. It's 10% infill 3mm walls. And it is able to press down quite a bit, you know. So I think it should be fine for this event. But again, that's something I really want to change in the future. So next revision, we'll have a carbon fiber side arm. But for now, this is just what we got. Anyways, and I can talk about, so the way this connects to the servo is, so this servo horn that came with the servo when I bought it, it's literally just put into this opening right here. And then we have the screws that just go through it and the TPU arm. And that's how it's held on pretty firmly. So that's nice. And the same kind of thing applies to the weapon motor. Weapon motor is just directly attached to the TPU arm with these screws that just go in there. And yeah, it's very simple actually, like way more simple than you'd think. So yeah, that's how the arm is assembled. Now, something I'm really excited to show is how I actually put the drill bit on. So I actually got the idea from a random YouTube video. I can't remember the name of it, but some guy did like a life hack to make like a very cheap brushless drill. And he got this drill motor and he got like a chuck and just put that on there and then put a drill bit on there and it worked. And that's how I got the idea to do a drill at this small scale. So I'm going to show you how I assemble the drill right now. So here's the first part of the drill chuck. First, we just put that right onto the shaft. Then we take this Allen key. Okay, hold on. I'm doing this while also looking at the camera. So if I mess up while fiddling around, that's why. But yeah, so we just tighten it around the shaft. Just like that. Come on. Okay. All right. So yeah, there you go. Now the first part is on there. Now we put on this piece. I have this in different sizes for different size drill bits, but this is what we got first off. You put that right there. Then we have the drill bit itself. Now this is nothing special. I literally bought a Dremel kit off Amazon for $20 and it just came with a bunch of random drill bits, like in this little case here. And I was like, hey, let's put that on a robot. Let's see how that goes. And this one's just a very basic drill bit. So, oh, by the way, so I've gotten recommendations that I should like try other drill bits. Like someone recommended that I try like a carbide drill burr. And again, that's something that I really want to do. And I'm going to see if I can do it in time for this event. But if I can't do it in time, I'll just save it for another event after that. But for now, we're just going to stick to the classic drill bit for this competition. So yeah, this drill bit just slots right in there. And then lastly, we have this part. I don't actually know the name of it, but we just turn it around like that, like how you would do for a normal drill. Just twist that. And there, the drill bit is attached. Real quick, something I'm going to do is I'm going to remember to put Loctite on this to make sure it doesn't loosen during a fight. But aside from that, the drill is attached, and that's pretty much it. It's a very simple drill setup. I don't know if it's the most effective, but that's just how I went about doing it. And yeah, this is the drill arm for the power of friendship. All right, so I've gone ahead and put all the electronics in, everything's soldered together, got everything attached. So yeah, let's do a quick little electronics test. So first we're going to try the drive motors. Okay. Oh, these are nice. I like these. I really like the repeat compacts. They're pretty cool. Now the weapon motor. Okay, now we drilling in here. And now the arm. Okay, that's pretty good. So yeah, good test. All right, now it's time for the next big part of the robot. And when I say big, I do mean big. It's the biggest piece for the robot. It's the giant TPU part that the forks mount onto. And yeah, it took a long time to print. It took like a day and a half for it to print, but it was worth it because it came out pretty well in my opinion. So as you can see, the forks just are hinged and they attach right to it using these sockets. And yeah, it's pretty good. Oh, by the way, the forks, I did not make them. They were actually made by Robert Runn from Team Crash Fest. He had a bunch of forks that he just didn't want. And one day he asked me if I wanted them. And I was like, sure. So yeah, he just gave me a bunch of these forks absolutely free. So huge shout out to Robert Runn from Crash Fest. Thanks for the free forks. I really appreciate it. So yeah, that's how they are. And looks pretty good. Pretty happy with it. All right, we got a lot of stuff here, and that's because this is everything we need to cast our wheels. So we have part A and part B for the Flex Foam 20 Free. As you can see, we need to put in a ratio of 85% A to 100% B by weight. So that's the ratio we got to do. So if we're doing, I think I calculated this, we should be doing 16 grams of part A, which means we'll do about 19 grams of part B. So we're going to put that in this cup right here, mix that together. We're going to weigh it on the scale to make sure we have the right ratio weight. And once that's mixed in, we're going to pour that into our wheel mold. But before doing that, we're going to spray it with this mold release. It's basically nonstick spray, but for, you know, these kinds of foams. We're going to spray that on here, so that when we pour in the mix, after it's solid, after the foam expands, we can easily take it out. But yeah, so we're just going to mix. We're gonna mix the right ratio of part A and part B. Pour it into this mold after we've put the mold release. We're gonna screw on the top, and then we're just gonna let it sit and let the foam expand. And then after a few hours, our wheel should be done. Now that whole thing is going to take a lot of time, and I really got to pay attention while doing it. So I'm not going to film that. So I'm just going to skip right to it being done. So hopefully that works out. All right. So it's been a few hours and the foam should be finished casting. So real quick, this is actually not my first attempt at this. I actually tried 2 other times before this, but I messed it up both times because my scale wasn't that precise. So I got the weight ratio wrong. So I actually went back and bought a new digital scale, and this one actually counts grams and weight and whatever. It goes to the decimal place, so it's more accurate, it's more precise. And when you're mixing these chemicals, it's really important to be as precise as possible. So yeah, that's what I did this third time around, and it looks a lot more solid. There's some stuff coming out through these holes because, you know, there's always going to be a little bit of excess stuff, so I just cut that off. But yeah, I think it should be good now. So we're going to go ahead and open it up and see how it goes. So just taking the screwdriver. Again, just wood screws put into the PLA. It's held on pretty well. Okay. And that should be it. And there you go. You can see the wheels. You can see some more of the little circle things that came out top. Again, I could just cut that off to make it smooth. So now we're just going to try to take it out of here. All right. And there you go. We got a wheel. It's a little bit more bubbly than I would have liked, but it's definitely still usable. I might need to try a few more times. I want it completely solid, but it's very squishy. And yeah, this should be pretty good. Gonna cut this stuff off. But yeah, that's a wheel. It's a little slimy because of the mold release that was still there, but I can just wipe that off. So yeah, overall, pretty good. Okay, and just like that, we've done everything we needed to get the Power Friendship built, or at least one of them. Now let's take a look. Here it is. The new Power Friendship. And I'm pretty happy with how it came out. This is looking really nice. We got the forks on. We got the wheels on. Everything looks pretty good. I'm pretty happy with this. So we got one of them done. We got one of them ready to go. Now let's go ahead and weigh it just to see what we got. Okay, there's my scale. Let's put them on there. Okay, so that's 1,070 grams, which I think converts to a little over 2 pounds, like slightly over 2 pounds, I think. So yeah, that's pretty good. So whenever we go back to NHRL, we can definitely easily cut down on weight somewhere to get it back to being 2 pounds so we can have both of them fighting together again. For this specific event, if I have time, maybe I'll reprint some of the parts with higher walls or be thicker or something since I have to wait for it, but I might not even do that. It might not even be necessary to do that, but we'll see. Regardless, the point is the bot is looking pretty good. So now let's take it for a drive and let's do some testing. All right, now we're gonna do a drive test. We're actually doing this one in my garage since there's more space, and the motors in this robot are actually pretty fast, which you're about to see right now. So let's go. All right, that's looking pretty good. Yeah, the robot drives pretty nice so far. Admittedly, it doesn't turn the best because of the longness of the forks, but aside from that, that's pretty good. Okay, I say that's pretty good. All right, now we're gonna do a test with the drill. Here's a TPU chassis that failed printing, so just gonna use that as a test target. So let's just see how the drill does. Let's do this. Okay, that went pretty cleanly through. That's pretty good. All right, we've already done TPU. Now let's see what happens when we drill PLA. Let's do this. Oh no, that went through. That is a hole. Look at that. Pretty happy with that. All right, time for our last test. This random plastic case I found in my junk drawer. I'm gonna be honest with you guys, like unlike the PLA and the TPU, which are actually used in combat robots, this has nothing to do with that. This has nothing to do with that at all. I just really want to drill a third thing just for the fun of it. Drilling things is just really, really fun. So here we go, let's do this. I have defeated the plastic case. All right, so those were some pretty good tests. The drive works, the weapon works, so we're pretty good. We're about done with this Power Friendship. We're done with the first one, but we still need to build the second one. So everything we just did, we're gonna do literally all of that all over again a second time. So I don't need to show you all that, so I'm just gonna skip right to the second robot being done right now. All right, I have gone ahead and built the second Power Friendship bot, and here it is. Looking pretty good. So obviously the bots are identical, except you've probably already noticed one big change, and that's the fact that this Power Friendship bot is actually in its anti-horizontal configuration with the wedge. So both bots have the ability to switch configurations. Both can switch between either the fork configuration that you saw with the other one and this wedge configuration. So the forks are for fighting verts and other stuff. This one's for fighting horizontal spinners. And like I said, since the bots are identical, I can switch the configuration between both of them. However, for this specific event, since I can only fight with one of them at a time anyways, the plan is just keep that one, the one you saw earlier, in its fork configuration, and this one in its wedge configuration. And the idea is just that I can just choose which bot depending on whom I'm fighting. So if I'm fighting horizontal spinner, I'll pick this one. If I'm fighting a vert, I'll pick the other one. And again, the bots are identical, so if for whatever reason something gets damaged and I need to put this wedge on the other Power Friendship bot, or take that Power Friendship bot's forks and put it on this one, I can do that. Because the robots are exactly the same. They have the same mounting and everything. And it's just going to be nice just to have a second robot ready in general. Can help with repairs. And yeah, pretty good. So the way the wedge mounts is similar to the way the forks mount on the other thing. And it's just these sockets that just go all the way through the TPU and through the brackets of the wedge. You also notice these higher walls on the TPU part of the wedge. That's just to help protect the neck, to make sure that if a horizontal spinner rides up the wedge, it hits this first and doesn't cut the arm off or anything. But yeah, aside from that, the robot's basically the same as the previous one. So yeah, again, this one's for fighting horizontal spinners. The other one's for fighting everything else. And it's just going to be really nice to have two robots, even if they're not fighting at the same time, just so that I can just swap out bots and parts whenever I need to. So yeah, second robot is done, and I'm pretty happy with it. All right, both of the bots have been completely built now. We got two bots ready to go. However, there's still one last thing we need to do. It's googly eye time. All right, one right there. Okay. And right there. All right, he's good. And time for his sibling. All right. There we go. Of course, the other side. And there you go. The Power of Friendship is officially back. And with that, we have successfully rebuilt the Power of Friendship. It was honestly really fun to put these bots back together, and I can't wait for them to finally get back into the arena. I really feel like I've improved the design, and it's going to be really interesting to see how the bots do. But of course, win or lose, I'm just excited to put on some entertaining fights for the audience. Like I said before, the Power of Friendship has quickly become my most popular robot, and so more than anything, I just want to make the fans happy. And just like that, this episode of the build process is done. We have officially built every bot we need for T-Town Beatdown. When I initially signed up for the event, I set a challenge for myself to see if I could build a bot for every weight class. It wasn't easy, but I'm very proud that I was able to do just that. At the time of recording, T-Town Beatdown is just a few days away, and you can expect me to make videos showing the fights for all of my bots, so needless to say, I have plenty more robot fighting content coming for you guys. I would also like to give a big thank you to everyone who joined me on this journey by watching these videos. I'm very happy that people have been enjoying the build process series, and it's definitely something I'm going to keep doing in the future. As always, I appreciate all the love and support. Have a wonderful day, everyone.